Hello everyone, my name is Mr. Zak van der Walt, and today we are going to talk about analytical geometry. The properties of lines that are perpendicular to each other, and we'll focus on this a little bit on today. Okay, let's focus on the lesson objectives. Describe the properties of lines that are parallel or perpendicular to each other. Calculate the gradient of a line using 2 points in space. And lastly, the student should be able to form a line equation that are parallel and perpendicular to the line f of x minus 3x plus 4. Okay, I have a question for you guys. Please give me the answer for you, or give me your answer in the discussion. Is it A? Oh, okay, what are perpendicular lines? Lines that never intersect, lines that have the same slope, lines that form a T when they intersect. Okay, indeed, it is number C, lines that form a T when they intersect. They form a 90-degree angle, to be more precise, when they intersect. Okay, next up, which one of the following lines are perpendicular to each other? Is it A and B, A and C, B and A, B and C, or C, B, or C, A? Give me a combination of two. Okay, Thabo, well done. Yeah, B and C, they are actually perpendicular to each other. That is really good for you to choose that one. Okay, yeah, you're really smart. Okay, I'll go into the solution for this a little bit later on. But yes, B and C is the correct answer. Okay, let's look at the gradient of a line. It is the measure of how steep a line is. For example, when you're walking up a hill, you know you're getting tired and the slope is higher. And when you're walking down a hill, you know that the slope is not so high. And remember, we're walking from 0 to a distance of 2. We're not walking from a distance of 2 to 0. I'm referring to the x-axis components. You're walking from left to right, not from right to left. Okay, moving on. We have point P1. It is defined there, and P2 is defined there. And if we substitute the components of P1 and P2 into the equation of the gradient of a line M, y2 minus ym, and divided by x2 minus x1, then we can get the gradient of a line. And we also know that M is the gradient, X is the X component, and C is the point of intersection with the Y-axis. This is knowledge you already know. Okay, moving on. What are parallel lines? Parallel lines are two different lines that cannot intersect, and they form the same gradient. They have the same gradient. Okay, so please think about why I said different lines and not the same line or something like that, because it's not the same line. If a line is the same as the other line, then they're not parallel, they are the same line. So that's why I'm saying different. Okay, moving on, we can see f of x and g of x is defined there, and note that if the two lines are parallel if and only if the following equation is true: m1 equals to m2. So this is saying if the gradient of the one line is the same as the other line, we know the lines are parallel to each other. Okay, and you can see that C1 and C2 is not considered it's not a prerequisite for the lines to be parallel. So you can have a one line 2000 units above the other line, they can still be parallel. Okay, now we are moving on to lines that are perpendicular to each other. Okay, what are lines perpendicular to each other? Lines that form a 90-degree angle at the point of intersection. Let's consider line g of x and p of x. Please note that I'm talking about a point of intersection. Perpendicular lines actually intersect, and parallel lines never intersect. Okay, having that cleared, the confusion, let's go on. Let's define g of x and p of x there, with m1 and m2 the component after the gradient of the lines, and c1 and c2 the y intersection. Okay, the following two lines are perpendicular to each other if and only if the following equation is true. m1 is equals to minus 1 over m2. Okay, so we can use this equation vice versa. We can find the gradient of the line p of x if we know the gradient of the line of g of x by substituting the gradient into this equation and using a little bit of algebra. Then you can find the gradient of the other line. So this is quite interesting to know. Okay, moving on. We have a class question. We are given f of x and g of x. Please determine p of x and q of x. And remember, this is a perfect square formed in the on the plane. Okay, Hendrik, well done, you got it right. D, please walk us through your method of getting to the solution. Okay, well done, you got it right, yeah. I'm just gonna talk about it more precisely. Okay, so we know the line P and G of x are parallel to each other, thus the gradient must be equal to 1. The same goes for line Q and f of x, whose gradient is equal to minus 1. We know that line P is perpendicular to line F, thus we use the equation of perpendicular lines m1 equals to minus 1 over m2. To find the gradient of the line P, it is equal to 1. Okay, the same goes for line G and Q. Since both lines G and F intersect at the y-axis at minus 1, we can only form a perfect square if and only if the lines of P of x and Q of x intersect the y-axis at plus 1. So that is why we get Q of x minus with a gradient of minus 1 and its y-intersection is plus 1. And P of x has a gradient of 1 and its y-intersection is at plus 1. Okay, last things. For next week's class, please bring me 5 practical examples of how you can use the things you have learned today to provide practical solutions for everyday problems. And please remember to complete your homework that is due on Friday. And as always, enjoy the rest of your day, and it was a lovely privilege to teach to you guys today. Okay, bye-bye.